the next session 3, Technologies and Systems for the Digital Transformation of the Society. The chair is Maurizio Mayer. We are different actors. We repeat table. Yeah. How the floor.
Thank you, Miguel. So now we are approaching the most crowded session of today, because we will have 5 speakers. And the theme of the session is the technologies and systems for the digital transformation of the society. So we finally arrived at the cue point. Digital society. Now, digital has now acquired a more wide meaning, because it's not more just a numeric reference, but all the new things that the new services that we are utilizing in nowadays, we like to call them digital. No? When we utilize the smartphone, we utilize the network, everything is digital. And so we need technologies to support this. And technologies can also push to the surface problems that were hidden before. I arrived in Madrid 2 days ago, and I wanted to look to my favorite football team match in Champions League. I have a link with a service provider in Italy. I pay monthly fee to look to this kind of events. But when I tried to reach it, I knew that, but I tried to reach it from my computer in my hotel room through the Wi-Fi. The answer was, we are not allowed to transmit the content, this kind of content, abroad. So the technology can put us in contact when we say every time, everywhere. Yes, but there are other considerations that are stopping this globalization of information. Before, that was hidden because, you know, it's obvious a television, analog or digital, are just a territory to cover. So obvious that they only have rights to transmit in their environment. But now, through satellites this morning, and through the overall internet, these boundaries does not exist anymore from a technological point of view. But they still exist. And these technologies, in any case, will push to modify the regulation. So now, let's give a glance to these technologies and systems. So I call back Edward, that is the 3rd time he's on the stage this morning, so I will not repeat his biography. I assume that you remember very well, including his granddaughter and the cat. And Ed will speak about building information communication technology, value propositions for the post-information age.
Thank you, Maurizio. You'll be pleased to know that my granddaughter has supervised the building of her first robot. So that's a good start. We talked about revolutions. I'm going to aggregate up revolutions because there's a feeling that one is imminent. Oops, the right way around. So this is roughly the structure of my talk. It's really about how, as things change, what's our attitude to the market and how how do we exploit the new things that are available to us with new business cases. Oops, away again. So, economists have their own view of revolutions, and they tend to like to look in cycles, sort of 7 to 14-year investment cycle, a 12 to 25-year infrastructure cycle, and a technology cycle of 50 to 65 years. Now, such an idea of a cycle is easy to disagree with, and many people would, particularly cause and effect. The idea of these cycles for technology comes from a Soviet economist, Kondratiev. He was aware of the first 4 revolutions you see. The 5th one is the information age, which if you see that as starting in the mid-1950s, and you count a 50 to 65 year cycle, its time's just about up as a driver of economic growth. Where we're heading for is the post-information age, and you've had some ideas already today what that might be. But certainly the Internet of Things and artificial intelligence will be key components. But there will be several other components, many of them outside of IT, so genomics and other things. So this is about to happen to our industry. What does our industry look like today? We wanted to think about markets, so we simplified it right down. We thought of, on the supply side, 3 sorts of people, 3 sorts of organisations. Network service providers, who provide infrastructure that perhaps we're most familiar with, and they provide several services across that. Internet service providers, who provide a subset of those services, and over-the-top providers. But we also divided our customer base up into 2, which is fairly common practice in telecoms. We have commodity sales, so that's a single product, such as MPLS or broadband. Typically, very simple pricing, highly standardized service, served from a pool of resources that are fairly anonymous. And they're what most people buy and most small businesses will buy. And they are extremely vulnerable to the activities of over-the-top providers. But on the other hand, you have solutions. These are what big customers with a lot of market clout buy. And they tend to be blends of products. And often those blends involve components that the network service provider can't provide in-house, that he has to go outside. And these can be basic things like feet on the ground in a foreign country, or it can be sophisticated IT components. These tend to have highly bespoke service levels, highly bespoke wraps, and tend to have teams behind them that customers can identify. And they tend to be fairly impervious to the activities of over-the-top providers. And they generate a very complex sales scenario. It'd be lovely if you could automate this and get it over with in a couple of hours instead of the many months it takes. What happens is the customer has to come up with his requirement, has to satisfy his business that it's going to deliver business benefit, has to satisfy IT that it's in keeping with what their strategy is and that it's not something they could do anyway, and has to satisfy procurement that that's a good deal. Probably has to bid to several network service providers that he'll often get a consultant to manage, and while all that's going on, a primary technology provider will also want to get in on the act and see that his product underpins the overall solution, and he will try and influence everyone he possibly can. So you get a very long, complex and confused sales cycle. So what does this mean for partnership? Well, products and solutions, which are the two things we've been talking about, tend to have quite different models. And the big thing about products is now they're subject to much more influence from the OTT providers. The OTT providers have a growth rate of 20%, are pushing up the need for network providers to provide more of everything at more or less the same cost, whereas network service providers' revenues are growing at 2%. So you kind of think that if the network service providers could get alongside the OTT providers, then they would get some kind of synergies and generate some kind of commercial benefit. But that tends to be very difficult because the two camps don't really understand each other. On the solution side, however, things are much more developed. The various players understand each other, they understand the customer's need, they realise that they can't survive without each other, and you have much more well-established models. But what we would suggest is that partnership is a very important part, and you have to consider how you'd arrange those partnerships, and modelling a hybrid business model that takes into account partnership becomes very important. So it's important for each player to understand where they add value, where potential partners may add value, and how that can be packaged up, and then go away and assess that both on the traditional profit and loss methods, but also by looking at what benefits they bring to the partners and the client. So the financial gains and penalties of doing that can be taken into account. So let's have a look at how those things might be modelled. This is a very simple model from some researchers who look largely at price with a very simple equation, and as you can see, the price has a twofold effect. It can increase your revenues, but it also decreases the customer's willingness to buy, so it suppresses them as well. At the same time, you're also looking at what welfare the client might get, and as you up the price, their perception of the value of the service goes down. We've sort of replicated their work here in these slides, and you can see just those effects. So on a very flat pricing model, you ultimately deliver peak revenue at a point, and these are relative prices, not an absolute price, but all the time the welfare goes down. You can make those models much more sophisticated by bringing in extra partners and looking at how each of their pricing affects things. You can also model partnership overall, and this is a particular piece of work that we think has mileage in it for looking at partners. You actually look at the propensity of partners to get on with each other and cooperate, and at the same time look at which partnerships give the lowest energy profile, in other words, give the most stable partnerships. We've tried to look for evidence of this in the marketplace. That has been extremely limited. This is a model of how broadband is provided to rural areas in the UK. Now, broadband is what we would call a commodity product, but in the end, in rural areas, it comes to bidding to provide an infrastructure, and that has to be done very much on a bid type process. Looking again at the market practice in Europe for smart metering, we had a look for evidence. Were there any sophisticated market models that people were using to evaluate benefit and the benefit of partnership? What we found is very strong understanding of cost, well-articulated but tenuous benefits, and controls that stopped well short of partnership in terms of they tend to be imposed by either regulation or competitive tender commercially. We did find possibilities for taking a more educated, established estimate of what partnerships might look like. So why do we see this return time and time again to the traditional ways of evaluating things? We've tried to explain this in the past using Kuhn's model of scientific revolutions. We've taken a slightly different approach this time. What we've said is that generally modelling things, especially complex situations, tends to fall into the sphere of fairly sophisticated thinkers who like to go in things in great detail. Yet the majority of big business decisions are made by quite extrovert people who like simple answers, like to act rather than ponder, and that creates a barrier that thinkers have to get over. You can take that from the individual level on the bottom, and that maps to organisations. If you know Handy's model, Gods of Management, that also speaks to a very similar model. So we think we've shown that it's very important to get some clarity in business cases and get away from just looking at profit and loss, but also take into account benefits, selecting the right partners, particularly with the post-information age, particularly when there are new challenges to face, and particularly when it's going to be very important to pick out the kind of propositions to take to market, because no organisation has the resources to take everything to market. And we're currently considering fresh approaches that we might take in taking this work forward. Thank you very much.
Thank you, Ed. I believe that it's better to put all the questions at the end of the session for all the speakers. So now is the turn of Berit Schubert from Germany. Berit is a Senior Vice President, Strategy and Corporate Development at Unify, the Atos specialist for communication software and services. In her role, Berit is responsible for business strategy, strategic business planning, competitive and market intelligence, and strategic program. In her presentation, Berit will talk about new requirements for the workplace in the context of digital transformation, obviously taking into account the experience in Unify. Please, Berit. You have 10 minutes.
Thank you, Maurizio. Good afternoon, ladies and gentlemen. It's a pleasure for me to be here, so thank you for the invitation. I will talk about empowering the digital workplace in the context of digital transformation. So when we talk about digital transformation, and digital transformation is a mega trend, as you all know, we should look at two different aspects. One is the technological aspect, and the other the transformational aspect. The technological aspect is the more obvious one. That means IT-supported business processes and workflows, automation and integration. And that itself is nothing new, so the IT services industry has been offering that for many years. What is new is the transformational aspect. Transformational because it is a driver for significant change, a driver that brings changes in economy and society. In the Atos Thought Leadership Program, Journey 2020, the term digital shockwaves has been created to better illustrate the magnitude and power of this transformation and sometimes disruption. So when we look at the impact, what are the areas that will be transformed? So there's first business models that will be transformed. So data, connectivity, and transaction systems have changed and enable new ways to organize a business. And Uber and Airbnb are just perfect examples of this, and many more new enterprises will emerge. Secondly, new ways of working will change. So the digital workplace is much more virtual, collaborative, and flexible, and people will collaborate with machines and virtual beings in new ways. So just think of Alexa, for example. And then thirdly, disruptive technologies. So with highly increased compute capacity and connectivity, the Internet of Things will further develop, enabling connected objects to self-organize and configure around the changing needs of the users. And we will see, or have already been seeing, a phenomenon, that a shift from mass production to mass customization, or actually full customization at a low or at least an affordable price. And customized sneakers or handbags are just the very start of this. And then lastly, with artificial intelligence and analytics, the challenges around identity, privacy, and security will increase. So why is the digital workplace so different from a traditional workplace? Well, because there have been several paradigm shifts. First is, work is no longer a place we go to, it's a thing we do, and we can do that anywhere. Secondly, because the digital transformation accelerates change, work is organized in a more agile and project-based approach, with experts very often being geographically distributed, and that calls for different tools and support structures. Thirdly, millennials have an expectation of more flexible work lifestyles, and retaining top talent for enterprises means allowing them the tools for a productive work experience. And lastly, collaboration, mobility, and ubiquitous access to networks and the cloud are now a given. So therefore, we can say the digital workplace is mobile, connected, virtual, collaborative, and flexible. In the past, tools have been purely technology focused, but what we actually need is, in order to enable the digital workplace, we have to look at the people. So enable virtual teams to succeed, dissolve, remove the feeling of remoteness for remote workers or anywhere workers, video calls in good quality, file sharing, screen sharing, chatting, all these things. Provide tools that are intuitive to use, that put user experience first and that are also fun to use. And lastly, make people engaged. So studies show that the commitment and engagement increases considerably when people can actually see the person they are talking to rather than just talking into a phone. So just remember, it's a digital workplace, it's a fully virtual team, and it's online meetings, and we all know how unproductive sometimes online meetings can be. And I have brought some market data that is a proof of this need for collaboration tools. So here you can see in the upper part the established enterprise communications market at a fairly moderate growth rate. And in the lower part, you can see the UCaaS market. That's the UC and collaboration market. And this is growing at a double-digit growth rate. And collaboration nowadays happens in the cloud. And it just shows how analysts, how big analysts estimate the requirements and the need in the market for tools like this. This growth is also influencing other areas of growth, and so telecommunication vendors can take advantage of that. So, for example, the segment of IP platforms and devices is growing. So in many countries there are all IP initiatives going on. So, for example, in Germany there is an initiative by the carrier Deutsche Telekom going on to switch to all IP. Then in the small medium enterprise market, we see in general a higher need for digital transformation. And also, this segment is growing because new enterprises typically start here. And as we just heard, the digital transformation leads to the emergence of many new enterprises. Then thirdly, increasing customer service importance. So when there is no local shop or no local office anymore, there needs to be something in the virtual world. So contact center solutions are growing fast, collaboration for contact center, etc., because you have to be accessible for your customers. And then lastly, the advent of CPaaS, or the platform idea, so communication platforms as a service, which means that collaboration tools increasingly get integrated into other applications or other hardware. So the digital workplace has many different facets, multiple facets. It's not just about startups. So when you look at deployment options, it can be in a cloud environment, but it can also be on-premise. It can be in a large enterprise or a small, medium enterprise. It can be about traditional UC or next generation UC, what is nowadays called collaboration. And it consists mobile devices as well as meeting room devices, and of course across industry-specific solution scenarios, and an increased focus on customer experience. So at Unify, we have put a lot of research into work styles, into a new way to work, into new work scenarios, etc. And we came up with Circuit, our innovation for the digital workplace, and the idea was to put people first, put teams first, empower the digital workplace, and hopefully humanize the digital workplace, and all in all, making collaboration better. Thank you very much.
Thank you, Berit. So let's proceed our European tour, calling a Spanish colleague, Joaquín Salvachúa, that is Associate Professor at the Telecommunication Engineering School at the Universidad Politécnica de Madrid since 1999. His research and teaching duties are related to cloud computing, big data, blockchain, and identity and security. Has been involved in the FiWare project since its start and is member of the steering committee in charge of security and big data generic enablers. He will speak on an agile container-based approach to TaaS. Please.
Thank you.
Yes.
Hello, good evening. Thank you for inviting us to here. We are related to the FiWare project, that is something that is a European project that is intended to make an ecosystem of applications and components that are able to compete with the ones in America. You know that most of the advance in the software-defined world, in cloud computing, software-defined networks, and on all the tools are not anymore on the telco industry. They are on different companies, American ones that are Amazon, Google, etc. They have all the knowledge, they have all the tools, and if you want to build something, you have to use their infrastructure. You cannot trust them because they have their own ideas of privacy. So if you want to build something, you have to start from scratch. The idea of the FiWare project is to give a set of tools that you are able to build an Internet of Things. Several smart cities in Europe and in Asia and some in South America are using right now this technology. And it tries to give a solution, open source, because it's the only way that you can trust this kind of infrastructure. After the problems with the diesel measures with Volkswagen, you cannot trust most of the things that are black boxes. You have to have access inside it. So open software is the only way to go in this kind of things. So we will try to build an ecosystem, right now as Europe Center, that try to have a lot of components that are able to solve all the things that we need to build. These components, we call it a generic enablers. We call it generic enablers, and everything is public. All the information is over there, so this is the advantages of this project. Initially, it was founded by the European community, but right now it's a foundation and is trying to live on its own. And there we have several components that we try to give solution to all the things that we will need to have for this kind of things. We have a lot of aspects we have there. We have a solution for IoT, for web, for machine learning, so cloud computing, for all the kind of thing. I don't go in details because we don't have much time, but we have a lot of components. Since our approach is try to give some kind of, let's say, quality to these components, we try to make automatic testing of these components. These components that we call generic enablers are able to be deployed. They are developed by a lot of European partners. Most of them are based on other open software projects. Others are developed from scratch, depending on the problem that we have here. But we need to assure that everything works. This is a huge amount of work, and we try to build an infrastructure that is able to handle this. We develop an infrastructure that is able to make testing as a service. As you know, everything in the cloud now is called as a service, so we go with the fashion and add testing as a service, where we can assure that every component that is developed by different people, and also they are doing versions in an agile way. This means that could be versions every week or every month, or depend on the speed of each of the components. But we have a huge amount of generic enablers and a huge amount of versions. We should have something very agile that is able to do this on demand, and also could be automatized as much as possible. There, we try to make something scalable. It uses the same infrastructure that all the project use. It's based in our case, all the infrastructure we are using is based on OpenStack. OpenStack is the solution, the only big solution that is able to handle cloud computing. Is what perhaps the huge open software project in the world. Was started by the American government, but now it's people all over the world is contributing to this. And we are trying to make something that works on this. As you know, everything changed in the last year because in cloud computing, we changed from virtual machines to lightweight machines. This is the Docker is an American solution, but it really has changed all the way that we can handle all these kind of things. Lightweight virtualization, the containers, allows us to put more virtual machines inside the same hardware. It makes more agile. Well, it has a lot of advantages. Due to the time that we have, I cannot enter in details, but later, if you want, we can talk about this. So, we have now developed the system that we are able to decide which of the components we are going to test, over which virtual machine or software will be run. We deploy it automatically via the automatic deployment tools that allows this as a software, make a test that it is running and is behaving rather well, and we get the test automatically. So we are able to have a testing infrastructure very fast for a very huge amount of different components that we have over there. So we are able to handle all these kind of things with this kind of systems. The details is that we can have different operating systems depending on the component that we are having. We have also different providing software. We are using Chef, Puppet in Murano. Chef and Puppet are the usual tools for doing this, and Murano are the ones that are inside OpenStack. We check all the dependencies and the syntax, and we make these components very easy. We have also put a RESTful API in, so we can automatize this, and it can be controlled as everything that we have. Everything is open software. We are putting everything in GitHub. That is now the center of the world for this kind of things. There we have also authentication in order to protect this based on the protection that OpenStack provides. That is the OpenStack Keystone. That is the one that we are using in the project. We have modified slightly to handle the web standards, to be able to handle the OAuth2 way of authentication, but it's quite easy. This is an example of how the interface it works. We can handle in a very low demanding environment. We don't have very big hardware in order to run this, and we can run it in a very simple way, this kind of things. Since we have all the infrastructure running in different versions of virtual machine and containers, we try to measure all the details, how long it takes to test, because sometimes, you know, that in very, very complex systems, the test could take days or even weeks. So we try to optimize this and be able to make some measures. The measures are in the article, but here we have some speed. These are the comparables are against the Dockers, the lightweight virtualization, and you can see that the lightweight virtualization makes everything more faster. Not only due to the fact that everything goes faster, but also the way that it starts and it deploys. Via OpenStack, the usual QQM, that is the normal hypervisor, there we have 34%. And using something that is used in every computer, that is VirtualBox, we get also some speed gain. So we are able to manage the process of making automatic tests for a huge amount of components. These components are from this project, and it uses the same infrastructure that the others, so it's part of the, let's say, smart cities components. We guarantee that we have a quality of services, we can provide different things, and also we are able to do it all batch or on demand when everyone publishes something on GitHub, for example. We can make automatic this. This also could be used as the same infrastructure. We have used this to build the Docker container, you know, that is similar to images in the case of the cloud computing, and this way we can automatize all the process of getting this kind of images. Right now we are checking different solutions to make it even a bit faster, and we are changing to the new technology. You know, right now the cloud orchestrator like Mesos and Kubernetes are something that this year also is being used in all the internet companies, are slowly going also in the telecommunication companies, and we are adapting this solution in order to be able to use this orchestrator for the cloud solution. Thank you, and questions later. Thank you.
Thank you, Joaquín. Now let's go in Greece, and
we are still in Spain.
It's a virtual tour. Virtual. So let me introduce George Agapiou, that besides to be a friend of mine, is a researcher, and he works in OTE research. You know, OTE is the incumbent operator in Greece. And he will present a paper entitled Service-Oriented Cloud Customer Premises Equipment as a Means of a Future Terminal. Please, George, 10 minutes.
Okay. Thank you, Maurizio. So my name is George Agapiou, and I'm coming from OTE. OTE is a telecom operator in Greece, and it's part of the Deutsche Telekom group. Just to make a small correction, I'm not a researcher. I like to do research, but I'm responsible for a lab where we test different technologies for OTE, especially the wireless technologies, the Wi-Fi and so forth. So what I'm going to talk today is, I think it was Andrei and Raf who talked about that most of the hardware in the future in telecommunications is going to be changed to software. So we had a project where we we wanted to see how really to virtualize and softwareize some satellite infrastructure. So we had a project which combined satellite and terrestrial, like wireless technologies, and we wanted to see how to softwareize the satellite infrastructure, because we know pretty much now we have for the wireless sector, the mobile technologies, they can be softwareized. We have the Cloud Run, what's called Cloud Run, where we have the access network, some of the hardware of the access network changed to software and it's moved to the cloud, which means it's moved to, let's say, to a server, to a PC that has an IP address somewhere in the cloud where people can have access from the operations department of the company. So just to give you a little bit of background, we see here, I mean, we have quite a bit of people, old people here, so we know what we had in the past. Here is still we have that, eh? Okay? I mean, in OT, we still have this one. So we have equipment which are, we have a lot of hardware. We used to have analogs, many buildings of equipment, of switches and so forth. So we moved next to the digital equipment, where some of the equipment, some of the hardware was softwareized. So the hardware was shortened, let's say. And now we have to move to a new era where most of the hardware is moved to software. So here what we see is that the software can save space, but also can save CapEx. Also part of what we do here in my lab, in Greece, in my lab is we test, as I said, different technologies, and also we test different terminals. So for example, we test the modems that we have in our house, and actually I'm responsible for testing the wireless part. So we test the Wi-Fi of the modem, and also we test, sometimes we have modems that have a USB interface where you can put a 3G or LTE USB in order to have access to the mobile technology. So the idea behind this is that the modem we have in the house is very complex. Even if you see it like to be very small, we have always customers who say, you know, I want this service, I want the other one, and all of these services do not go to the network. They go inside the device. They go inside the modem that we have in our house. So the idea is to see how to move those functions that the people ask. For example, they ask to have like parental control, they like to have VPN service, they like to have different kind of services. So we like to see how to centralize those and put them somewhere in the cloud where it's much easier for the operator to manage those. And it has to do it one time. It doesn't have to download all those services one by one to each house. So actually what we do now as an operator, if we have to put a new service, we have to put this service inside the box of each customer. So during the night, we have a system, a configuration system, management system, where during the night we download this service to each user. So it would be nice if this service would be in the cloud centrally, so the traffic would go straight to that to the cloud instead of going to each house separately. So we can see all those functions that you see here. What we see here is the CPU is just the modem. Okay, it's the modem that we connect to the internet. So we have different main functions installed inside this modem. So actually in this project was, the idea was to see how virtualization can take place and how this modem can have terrestrial access, as we have now. We have the wired cable where we connect it to the fixed operator. We have a mobile interface through USB usually that's connected to the mobile operator. And this box also has a satellite interface that can be connected also to satellite operator. So we examine 3 different boxes. We have the classic box that has all the services. It's the one we have right now in our house. We have what we call gray box, that some of the services that it has inside can be moved to the cloud. And we have also what we call white box, that most of the services which are found inside the modem are moved to the cloud. So the idea was to compare, at least financially, which one of those three boxes was most viable for an operator, let's say, to have and offer to the end customers. So here, again, we can see the infrastructure, and what you see, at least on the right, is the architecture where most of the services is moved to the cloud. So again, here we can see different technologies in the access. We can see those on the bottom line. We can see, for example, Wi-Fi, WLAN. We can see the 5G new radio. Now in the 5G, they try to move in high frequency in order to achieve this high capacity that's required. We have the LTE, and we have all those functions that you see in the middle, like routing, DPI, deep packet inspection, quality of service, monitoring, the NAT, the firewall, as I said, parental control, VPN services. Those are found inside the in the cloud, where they can be managed by a controller. And what is proved is that this way is the way to go to the future, of course. And this, in this way, most of the operators are going to move. Again, here we can see the infrastructure. We can see most of the functions in the middle in the cloud, which is called RAN cloud or cloud CPE. In the cloud CPE, which is part of the RAN cloud, is where you can find most of the services which before were found inside the boxes. Here we can see some of the financial analysis that we did. On the left figure, we can see the cash flow, which means how much money the operator, let's say, has right now. So what we compared here is, as we increase the number of customers, supposedly, actually, in OT, we were obliged actually to decrease the number of customers because we had some different operators also coming to the market. But we can see in the left figure, we have three curves. One curve, the lower one, is for the classic CPE, for the classic modem that has all the services inside. The next one, the orange, is the one that talks about the gray box that has some of the services virtualized and is softwareized and is found to the cloud. And we see the top one curve that gives most of the money for the operator, let's say, is the one that talks about most of the services to be found in the cloud. And also we can see in the right figure, we have the EBITDA, which means the money that you have before the tax deduction. So it's the money that an operator makes before we deduct it from the taxes. And so we can see for the classic box, which is on the left, we have the less money, and for the more money that an operator can get is for the white box. So those curves were estimated for the year up to 2021. And here we can see the break-even point, which means what is the year that an operator can make its money. So when we have an investment and we spend money and we want to see when at least we can cover this investment, that's what is called break-even point. So, and we can see that for the white box that has most of the services virtualized, pretty much we achieve the break-even point, as we can see here, in 2 years. And that's also, we did some what we call sensitivity graphs, where we change some of the parameters. For example, here on the right figure, you can see we increased the price of the box of the modem by €2, and still we saw that the break-even point, which means the operator can make its money, it's about 2 years, if he virtualizes all the functions of the modem. So as a conclusion, we can see that the price of a CPE, the price of a modem decreases as the network functions, or the services, let's say, which are built inside the modem, increase and they are moved to the cloud. And also we found that provisioning, which means that if you have to install a new modem to an end user, to a customer, the configuration cost and the operation cost also decrease as the number of those functions are moved to the cloud. So thank you very much.
Thank you, George. So let's go back in Spain, so George will be happy. With José Luis Martín from the Polytechnic Universidad of Madrid that will present a paper entitled Can Learning Methodologies Contribute to Develop Digital Competences in Telecommunication Engineer Education? Big question.
Thank you. Thank you, Maurizio. I'm going to present the paper. This paper has been developed with Zoraida Frias, the chain assistant, and Jorge Pérez, full professor, both of them from the Telecommunication Engineering School at the Technical University of Madrid. I have organized this paper in 5 parts. This is the structure of my speech. Digital transformation is deeply affecting the economy, while forcing companies to transform and adopt new competition drivers. In most sectors, the value chain and the traditional relationships between companies are suffering deep structural modification. This new paradigm may become an opportunity to promote innovation and create value. However, this change incurs additional costs and risk, and not everybody is ready to face them. According to the results shown in the report entitled The Future Jobs, Employment Skills and Workforce Strategy for the Fourth Industrial Revolution of the World Economic Forum, a high percentage of professionals has not developed the digital competencies needed to face the new emerging roles. One of the recommendations of this report is the need to rethink the educational system and encourage the joint across business and education institutions to figure out what a true 20th century curriculum should look like. Over the last few years, higher education curriculum have been reviewed and adapted within the European higher education area, and the professionals trained in this degree are now entering the labor maker. It appears to be soon to introduce new deep change in the curriculums because the designation of these new students is digital natives, millennials, digital learners, Google generation, or AI generation. According to some authors, the current curriculum and the methodology is not designed for them, and the students' expectations are fully opposite to what the professor offers. The European Union, through the EU Science Hub, has recently published the DIGCOMP 2.0. Digital Competence Framework for the citizens, describing 21 digital competence group in 5 areas. These are in the next slide. Information and data literacy, communication and collaboration, digital content creation, safety, and problem solving. So what's the problem? Some authors conclude that school and higher education institutions are not getting a full assessment and amplification of the students' digital competence. And other studies point out the lack of the professors' digital competence training as one of the principal barriers in the development of digital competence. Professors need to be familiar with digital environments, new pedagogical techniques, and collaborative networks to enable such competence in others. The findings of others show 4 key areas to promote digital literacy: encouraging the participation and sharing of information in social media, assessing and researching digital information, promoting new communicative skills online, creating digital contents contributing to the internet using digital tools, and understanding the rules for reusing and copyright. Following this recommendation, our study case was developed due to the difficulty in modifying study plans, we considered to analyze whether the new learning methodologies can contribute to the digital competence. The study was accomplished in a course of the Master in Telecommunication Engineering at the Universidad Politécnica de Madrid. The course is entitled Strategic Vision of Technologies and System Integration of the ICT Sector. It is a 3 ECTS course taught during the first semester of the first academic year of the Master. The course have been developed 3 times since the creation of the Master, and in the last 2 editions, two experiences with innovative methodologies have been developed. The first one took place in the academic year 2015-2016. The assessment of the course was split in 3 parts: a case of a study, a theoretical exam, and an assignment gamified. This assignment consisted in developing digital content, choosing between a video or an essay about digital economy. All these contents joined to a competition sponsored by the Cátedra Telefónica Economía Digital, and all contents developed were published in the blog of the sponsor. The second one took place in the academic year 2016-2017, and the assessment of the course was split in 3 parts: a case of study, a theoretical exam, and online quizzes accomplished in the class. The quizzes were undertaken at the beginning and at the end of the class. First questionnaires analyze if students have read the previous materials, and once at the end of the class, analyze if they have followed the lecture. An anonymous survey about the experience was taken at the end of the course in both gamification and questionnaire experience. In both experience, the number of students in the first course was 153, and in the second course, the number was 128. The students were mainly male, as we can see in the first table, and in the gamification experience, most of the students work on essay with 73.2%. However, the assignment grades in the video category were significantly higher than in the essay. And finally, in the case of the final grade, no significant difference were found. A final survey of the experience with a sample of 68.63% showed some difference by category. All items were above 3 points, and in the items about motivation of the experience, useful and research, no significant difference were found. However, in the item about learning and satisfaction, students from the video category perceived the learning and satisfaction with the course significantly higher than the ones from the essay category. In the online quizzes experience, student scores at the beginning of the class was significantly lower than at the end of the class. This result was congruent in both practical and master class, and in similar survey than the previous experience, with a sample of 42.97%, the item best valued was satisfaction with the questionnaire experience, followed by the usefulness and motivation. Both the gamification of the experience and the online quizzes experience are strongly associated with some of the areas of difficult digital competences, defining in the framework of the European Union. In the case of the gamification, students work on the elaboration of digital contents, and this experience promotes the development of competence, digital content creation, information and data literacy, and communication and collaboration. It is important to note that academic performance of the student was significantly higher in the video category, and this effect was not significantly in the final grades, but it is congruent with the finding of the Havelic et al., who showed that students with higher development of digital competence get better academic results. On the other hand, in the mobile questionnaire experience competence about information and data literacy, communication and collaboration, and problem solving were developed. This experience was more interactive because in all the lectures, students got some feedback and had the chance to raise their doubts. Students' participation was encouraged according to ERSTAT recommendation. In conclusion, the challenge to develop the digital competence may be faced, including new learning methodologies in the course. Millennials have a different mindset, and getting them engaged require new pedagogical techniques able to meet their expectation. New innovative education models emerge with encouraging results: flipped classroom, gamification, learning service, augmented reality, lifelong learning, and more. In education must not be at the end of the digital transformation process. It must be at the front of it, so as to train the future leaders to understand the new digital paradigm. I'm sorry for my English, and thank you.
Thank you, José Luis. So now we have time for some questions. Please, Josh, a German representative.
Thank you. Questions for George. Somewhere in your presentation you mentioned in the profit before tax. My question is, in your break-even analysis, in your diagrams, is that profit before or after tax? Because if it's before tax, your break-even point doubles, more or less.
The break-even point you calculate with the money that you have at the time that you make the calculation. So it takes into account what money you have at that time, after 2 years, 6 years, which means, of course, after deduction, after tax deduction.
After tax, okay.
Yeah.
Please, Andy.
Thank you. So this is a question for Berit Schubert, please. I found it very interesting, the scenario you were describing about the change in the office place, really. And one of the things I just wondered is, given all the flexibility and people can work from any location, they don't need to be in an office and so on the other side, there seems to be, or is there, a great loss from the fact that you are not collecting together physically with other people, which no matter how many good electronic systems there are for conferencing and sending text and data and so forth, you can't beat the personal interaction of people actually together. Do you have a view on that?
Yes, yeah, that's right. I mean, technology can never fully replace the personal interaction, and actually it's not meant to replace that. I mean, it's there will still some travel be required and some face-to-face meetings be required, and that's perfectly fine. But for the meetings that happen online or for the virtual teamwork, it's essential to have to have a good tool and that supports this sort of work. So it's not one or the other, it's both.
Other questions? Okay, so let me thank, first of all, the past. Oh, Josh, another one. Okay,
One for Ed.
It's good question also for the Netherlands part.
You showed a lot of models with partnering, spiderweb partnering, I would call that, all kind of diagrams, and a lot of calculations. And I really wonder how much practice is in that.
Is that how widely it's practiced? I don't think it's widely practiced at all. It's that this was a point at the end. Very much we see a kind of resistance to evaluating things using more sophisticated tools because the more senior management don't understand them, and the people who are expert in them struggle to articulate what they do in a way that fits into a senior manager's attention span.
Okay, other questions? Now, so let me thank first of all, the passionate audience, and then our speakers for the quality of their presentation and for the perfect timing. So thanks a lot.